Hi, everybody. Before we start, this is really unusual, at least for the talks I usually go to. I would like to start with a question this time. So, do you really need WebSockets? And the clicker went off. No, I forgot to turn it on. OK. So, first to introduce myself, my name is Stanko. There's my contact information. I am a Ruby, Elixir, and Rust developer, primarily focused on backend. At the moment, I'm employed at Very Big Things. Those are the lovely people here in the first row. And when I got employed there, I have to say that I at first thought that it was only a marketing-friendly name. But when they gave me this email and no alias for it, I figured they meant business. Oh, it jumped like 10 slides. What? This email. This email, sorry. OK, so let's hope it works this time. So why do we use WebSockets? So the whole web is built around the challenge response principle, perhaps better known as the request response cycle. So how it works is that if you have a client and a server, we first establish a connection between them, and then the client asks the server what it wants and gets the response. So this mode of communication is known as a half-duplex connection. What it means is that at any point, only one side can send data. There is no way for both of them to send data at the same time. One has to ask something to receive the other one. Another problem is that connections only from the client to the server are possible. So this works out pretty good. I mean, the whole web is built around it. I mean, there's a whole room full of people here that basically only use that. And what is really the problem? Have you ever tried to make a chat app? How many people try to make a chat app, like, at least once? OK, half the room. So you know the problem. It would be really, really hard to build a chat app in this way. If you constantly have to ask to receive, that means that you would have to refresh the page every now and then just to get data. You can solve that problem by basically just asking the server periodically, let's say every second or so, to give you the data it has. But that problem becomes only apparent, like this is really good, but problems become apparent with this approach. If you have one client and one server, no problem. If you have two clients, one server, no problem. What if you have thousands of clients in one server? That becomes a problem. Your server will start spending more time responding to I have no data than actually processing the requests that all the clients make. Another problem which you might think of is blackouts. So what is a blackout? A blackout is the period between when the client asks for new data and the server responds. So basically, every time the client is waiting for data or is waiting to make a new request, it doesn't know if there is any data. This is called a blackout. And why are my slides going by themselves? Something is terribly wrong. I'm abandoning this clicker. Yeah, blackouts. So this is really bad. Yeah, OK, sorry. Something went completely off whack. So we can lessen this problem by just decreasing the time interval between the client asking, and the server responding. And sorry, some technical issues. OK. Yeah, OK, we're back online. So let's just go for blackouts again. So blackouts are the period between, and basically you can lessen blackouts by decreasing the time interval for when the client waits to ask new data. And this solves the problem a little bit, but the real problem then arises. You're increasing the load on your server even more. So to solve this issue, we can go for a full-duplex. We can go for a full-duplex connection. What a full-duplex connection is, as you configured from before, is that full-duplex connections enable you to send and receive data simultaneously. This is why we use WebSockets. WebSockets enable us to create real-time communication between the client and the server. They were first introduced back in 2011. That's nearly 7 years ago. Sounds like ages. And they were introduced by Google. Does anybody know why Google created WebSockets? Nobody? Yeah, anyways, they were introduced for the Google Wave project. Perhaps you heard of it. So the whole point why WebSockets got created is so that you can see what other people were typing, like as they were typing the message they wanted to send you. And this is also part of the reason why the protocol is, well, interesting. So after a regular old HTTP connection is established, we send a request, and the server responds with an HTTP 1.1 upgrade request. After that point, the HTTP connection is completely dropped, and we switch to another protocol called WebSockets protocol, which is part of the HYBD groupation. And after that, we can finally send data asynchronously between the client and the server. So if you want to know how that looks in the browser, it's really boring. You only get like this 101 on the left side, and that's basically it. It's nothing really special. But the important thing here is that every WebSocket starts out as a plain old HTTP connection. And this is super important for 2 reasons. First is authentication. Now we can use all our old tools. You can use your favorite authentication framework, as always. And another is backwards compatibility. If a browser doesn't understand WebSockets, it will just say, I don't understand this request, but still a request got made, and you can track that. The cool stuff is that they're part of HTML5. So in every browser, mostly any browser, you get this kind of nice interface which enables you to create connections. But most of us don't use it. Most people just use Socket.io or some similar library to it. So they support up to 1,024 connections. This will become important later, you'll see. And they can detect joined and dropped clients. Perhaps you've seen that on most applications when somebody comes online, they get a green bubble next to their name. And they have no reconnection handling, which is weird because people usually use Socket.io and then claim they do, but WebSockets don't have that at all. Another issue, which perhaps some people in the sysadmin or ops field know, is that you have to configure a proxy and load balancer to work with them. So for instance, Nginx, if you use it, won't work out of the box with WebSockets. It will actually drop the connection after the upgrade. This is mostly because WebSockets aren't HTTP and Nginx doesn't understand it. So let's go back to our problem. Did WebSockets solve our chat issue? Well, yeah, they did. But what did we lose in the process? So first off, we split our application into 2 applications. So now we have an HTTP server and we have our WebSocket application. And this means that we basically have 2 control flows for the same thing. So if you want to send messages over HTTP or messages, which you usually need to do because you need to prefetch them, or messages over WebSockets, that means that they have 2 serialization logics, 2 completely different data flows, which could pose an overkill solution to the problem. WebSockets are really cool technology, but where they really excel at is voice and video chat and games, or in much broader terms, anytime the client has to send data to the server whenever it wants, so asynchronously, however. So people usually ask me what the alternatives are, and actually this whole talk started out as a question. People ask me at least once a year, how can we do this? How can we implement a chat? And I usually tell them, well, take a look at server-sent events. So do people know about server-sent events here? Usually, okay, there's a fair few. So server-sent events are actually really old. And the cool stuff about server-sent events is that they're pure HTTP, like no magic, no different protocol. So we open up an HTTP connection and everything is done with it. But it comes with a trade-off. We can only send data from the server to the client. How they work? It's pretty simple. So again, we open up the connection, and after the connection is made, a regular old GET request is made. And after the GET request is done, the connection is kept alive because HTTP 1.1 allows us to do this. So after the connection is kept alive, we just send data back. anytime we like, because we keep it alive so the client listens. You can usually notice that if you have like a long pending, never-ending GET request. So that's usually the best way to notice if somebody's using SSE. The downside of the whole thing is that Microsoft, for some reason, doesn't want to implement any native APIs for it. But since they are pure HTTP, there is literally a polyfill that adds them to all browsers that support HTTP 1.1. In all other browsers, there is a really nice API. You'll notice that it's much simpler than WebSockets, mostly because the whole protocol is a lot simpler. Also, now comes into play the 1024 connections for WebSockets. SSE is subject to the 6 connection limit. So for people that are not front-end developers, the browser limits the number of connections to a single domain to around 6 to 9-ish, depending on the browser, just to optimize page loads. And if you would open, let's say, 6 connections, that means that you wouldn't be able to load anything else. The cool thing is that they actually handle reconnections automatically. So for instance, if your client drops, the browser will try to reconnect to the server automatically. Though, it can detect dropped clients. So the server doesn't know when the client dropped. It only knows that, only the client knows that and wants to connect. So why would you use like server sentiments over WebSockets? Well, we go back to our previous example where we now have only a single data flow. We only have our HTTP request application. And if we would like do a code example, which is here written in Ruby, mostly because Ruby looks like pseudocode to most people, we just have a regular old GET request. We specify like we have a stream route that responds to GET. We set the content type to octet stream or event stream, doesn't matter. And then we just stream the data out as a HTTP stream and loop indefinitely, just putting in the data into the stream. So you'll notice like that the data here is prefixed with the data keyword, and this is actually part of the protocol. So the protocol supports 4 keywords in total. The first and only one that's needed for the whole protocol to work is data. So there are 3 other metadata keys, which are event, ID, and retry. ID basically just says the ID of the event specifies the type of the event, and retry says how often the client should try to reconnect to the server in case of failure. The best application for SSE are text chat and notifications, or basically anytime the server needs to push data to its clients. But there is also another alternative that solves the exact same problem, and that's long pulling. So long pulling is usually accommodated with a stigma, rightfully so. It has some open issues, which I'll discuss now, but the best part is that it's pure HTTP. The whole principle works really basically that the server delays its response. So when the client asks, give me this data, the server just says, well, I'll wait. Or to put it in an animation here, we establish a connection, then we make a regular old GET request, and if there is any data, the server responds immediately. Then the connection is stored down, if my slides follow me. Pink slides. So, and the cycle begins again. So what that means is that, sorry, I'm fighting with my presentation here. What that means here is that the client basically after gets response, it tries to reconnect immediately and just waits for the server to get the response. Something is terribly wrong, sorry. So the client reconnects immediately, and the server responds as soon as it gets data. When the client receives data or if the connection breaks, the client immediately tries to reconnect. And if the server doesn't have any data for the client at the moment of reconnection, then it waits. It literally just says sleep, and it sleeps for 1 second, and then it tries again. So if you want to see how that works, like in practice, if you open up your browser window, it will look something like this. This is an example from IRC, and you can see that basically it waits for 3 seconds, then it kills the connection and just starts over again. The weird part is that there are no native APIs, but that's also the good part. You don't need any native APIs to implement long pulling. Long pulling just works. You can just make more and more XHR requests. You still have the problem of blackouts, but they're less apparent. They're basically the equivalent of shortening the distance between trying to pull the server to 0. They're still subject to the 6 connection limit, but with a caveat. The cool thing is that you're constantly making new connections, so you're also constantly freeing up old connections. And the best part, and the part why they're mostly still used, is they're supported everywhere. Again, we solved the problem of WebSockets. We have the same control flow. And this is arguable. I don't have experience working on a large-scale application using long pulling, but they're better for a large number of users. Perhaps this is mostly apparent if you go to Messenger and refresh a couple of times because Messenger has A/B testing. You'll notice that Messenger uses long pulling. Also, I gave the example of IRC. So what's the conclusion of the whole story? Which one is better, SSE, long pulling, or WebSockets? Well, I made this chart. It's really handy. People loved it. But there is a problem with this chart. If you use any kind of library for WebSockets or any kind of shim for SSE, the bottom 2 rows are basically the same. They all become true. And when it comes to browser support, SSE is supported everywhere where HTTP 1.1 is. So that's basically everything. And WebSockets have around 90 to 94% browser support. It boils down to implementation cost. So if your framework allows you to do WebSockets really easily, it would be better for you to use WebSockets. But if it doesn't, it would perhaps be better to try out long pulling or SSE, as you can implement them as a plain old controller in your application. If you do mostly push, please reconsider using SSE or long pulling over WebSockets. There are many handy advantages. For instance, WebSockets actually consume your connection pool. So if you have 1,000 clients, you have 1,000 connections. SSE suffers from the same issue, but long pulling doesn't. So you have to pick and choose what works best for you. Now, I would like to accept questions, but before I do, I'd like to give a question back to you. So do you really need WebSockets now? Questions?
Question here. Great talk. When it comes to battery life on a mobile device, which one would you prefer to do if you were running one of these on a mobile device?
So when running on a mobile device concerning battery life, I would guess that it's less overhead to do any streaming implementation, so be it WebSockets or SSE. SSE is only one way, so I guess there is less processing to do, but don't quote me on that. I guess long pulling wouldn't be your friend here.
Question in the middle.
Hi, nice talk, and I would like to comment, like, one disadvantage that you maybe forgot to mention is that long pulling has a really, really big disadvantage in bandwidth. How would you comment that? I mean, the bandwidth is much, much bigger than in WebSockets, for example.
Yeah, that's completely true. So just to repeat the question, the comment is that long pulling has a disadvantage concerning bandwidth. That's completely true. You have to pick and choose your battle, and if that's your concern, then don't do long pulling. If that isn't your concern, or you just want to try something out, see what sticks, so try something new for a client, I think they're a good trade-off to see if it works. If you notice that becoming a problem, if you have more and more clients, try switching out the technology. They're basically all the same when it comes to pushing data down, but if you want to push data up, then WebSockets are the only way to go.
Any other questions?
They're in the middle.
Yep.
Sorry. What do you think about combining technologies like SignalAir?
So can you repeat the question, sorry?
The technologies combining these platforms like SignalAir.
SignalAir technologies? I didn't understand the question, I have to admit.
Yes, SignalAir is the Microsoft implementation in a negotiation protocol.
I didn't hear of it. I really can't comment on it.
Okay.
So.
What about from a server standpoint, which technology would support more clients?
Sorry, can you just say which standpoint?
From server side.
From the server side standpoint.
Which technology would support more clients?
Long pooling, by far. So long pooling is just regular old HTTP requests. If there is something that your server is good at, it's good at doing HTTP requests. Then afterwards comes SSE, and afterwards comes WebSockets. SSE is just above WebSockets, mostly because it's HTTP, and your server already knows HTTP. For WebSockets, depending on your framework, they're usually pretty jankily implemented. This is mostly because WebSockets start out as a HTTP request. So there has to be a handoff between the HTTP server and your WebSocket implementation. And for instance, I worked with the Ruby implementation. It's done in a really janky way where basically the web server gives the raw socket to the Ruby application, and it's really, really dirty under the hood.
Another question on your left.
Hi, hello. Maybe I didn't pay much attention, sorry for that, but how does SSE know, in the SSE protocol, how does server know when to stop sending messages to the client?
I knew somebody's going to ask this question. So there is this thing. It's not animated. My slides really suck. Sorry for the slides, people. Heartbeats. If you use WebSockets or server-sent events, you really need to keep a heartbeat. The heartbeat is like what makes it all tick. So if you ever open up a connection like that, you'll notice that there are a lot of packets being sent back and forth, and most of them are basically empty. What that's for is just to notify the server that the client is alive and vice versa. So that's why WebSockets and SSE are basically the same when you start using libraries. So with heartbeats, SSE can detect dropped clients as well as do reconnection because it does it out of the box. And WebSockets also can by themselves detect dropped clients, but they now also can reconnect because they basically always try to ping the server, and that forces them to reconnect. But there is also another cool thing. That means if you keep a heartbeat, that means that anything in between your server and your client won't kill the connection because there is always data going through. So if we didn't have a heartbeat and we opened up a WebSocket or an SSE connection between the client and the server, after around 3 minutes, if you're using Nginx, that's the default, the Nginx would kill your connection, mostly because it's stale and it will think that it's unused. That's why you have to keep a heartbeat.